Hello and welcome to the class on regression. We have studied correlation where it indicates the relationship between two or more variables. Correlation is the statistical technique which measures the degree to which two variables fluctuate with reference to one another, and the correlation coefficient can be obtained with the formula Rxy is equal to covariance between variable x and variable y divided by standard deviation of variable x into standard deviation of variable y. Now if there are significantly correlated variables x and y, and if the variable x is dependent variable and variable y is an independent variable, then we can estimate the value of variable x, the dependent variable, if we know the value of variable y. With the formula x is equal to ay plus b, where a and b can be obtained with the given formulas. Regression is the statistical device with the help of which the unknown value of a variable from the known value of another correlated variable is estimated. The unit change in a correlated variable when there is unit change in the other variable can be estimated using regression. The meaning of regression is the act of returning or the act of going back. Independent variable regresses on the correlated dependent variable. The regression of variable y on variable x can be obtained with the formula bxy is equal to covariance xy divided by variance of variable x. The regression equation of variable y on variable x can be obtained with the formula y is equal to ax plus b, where a is the coefficient of y in the regression equation of y on x, and therefore the regression coefficient of variable y, whereas b is a constant. The regression equation of x on y can be obtained with the formula x is equal to ay plus b. The regression of variable x on variable y will not be equal to the regression of variable y on variable x. This slide denotes the difference between regression equation of x on y and the regression equation of variable y on variable x. For example, if we need to obtain two regression equations, length on weight and weight on length, from the given data, initially we can estimate the values of capital N, that is the number of pairs of the values, mean of the variable x, that is x bar, and mean of the variable y, that is y bar. Similarly, standard deviations of variable x and variable y can be obtained, and accordingly the correlation can be obtained as 0.8. Now, the regression equation of x on y can be obtained as x is equal to 1.05 y minus 2.40, where 1.05 is the regression coefficient or the slope and 2.40 is the constant. Using this formula, we can find out the value of variable x for any given value of variable y. Similarly, the regression equation of variable y on variable x can be obtained as y is equal to 0.61x plus 4.34, where 0.61 is the regression coefficient or the slope and 4.34 is the constant. Using this equation, we can find out the value of y for any given value of variable x. The regression lines can also be obtained using the given regression equations as shown over here. Initially, we will have to find out the estimated values of variable x and variable y using the given equations. These estimated values can then be plotted on the graph to obtain the regression lines. The properties of regression line can be enlisted as follows. If the correlation between the two variables is perfectly positive or perfectly negative, the two regression lines will coincide with each other. There will be only one regression line representing both x on y and y on x. If the degree of correlation between the two variables is high, that is close to +1 or close to -1, the two regression lines will be closer to each other. Whereas if the degree of correlation between the two variables is low, that is close to 0, the two regression lines will be distant from each other as shown in the given diagram. When there is no correlation between the two variables, that is r is equal to 0, the two regression lines will intersect each other at the right angles. The two regression lines intersect each other at the point of x bar and y bar, that is the mean of variable x and the mean of variable y. The distinction between correlation and regression. Correlation measures the degree and nature of the relationship between two variables, whereas regression gives the average change in the value of one variable when there is a change in the value of the other variable. Correlation is a two-way relationship between the two variables, that is rxy is equal to ryx, whereas regression is only one-way relationship. Thank you.